When we learn about if-else statements, comparison and equality operators, and Boolean values, we also need to learn about logic, and in particular about Boolean logic. So let's do that in this video. So basically, Boolean logic is a branch of computer science which uses true and false values to solve complex logical problems. And in order to do that, it uses several logical operators to combine true and false values. So much like we use arithmetic operators to combine numeric values. Now we're only going to scratch the surface here and talk about the most basic logical operators, which are the AND, OR, and NOT operators. And note that Boolean logic is actually not specific to JavaScript. This is all true for all programming. But anyway, let's now understand how these operators work and use an example to illustrate it. So here we have two Boolean variables that can either be true or false. So A is that Sarah has a driver's license, and B is that Sarah has good vision. So both of these are of course conditions that can be true or false, because Sarah could have no driver's license and she could have no good vision, right? And of course, on the other hand, she could also have a driver's license and could have good vision. Now, using the AND operator, like A and B, we can combine these two Boolean variables like Sarah has a driver's license and good vision. Okay, but now what will be the result of this operation? Well, for that we use a so-called truth table, which looks something like this. Here we have the two possible values for each of the variables A and B, which gives us 4 possible combinations of results. And so then all we have to do is to plug in the value of our variables and get the result of the AND operation from this table. So what we can see from this table is that only if both A and B are true, the result of the operation will be true as well. And that makes sense, right? After all, it's called the AND operator. And so again, what the AND operator does is to return true only if both A and B are true. In all other situations, if either A or B are false, then A and B will also be false. And we can also generalize this to more operands, so to more than just two values. We could do A and B and C, and the result would be true only if all of them are true. And if one of them is false, then the result is immediately false as well. Now, I know that all of this might look a little bit confusing, but don't worry, we will have an example a little bit later in this lecture, and we will also use this in practice in the next one. And after some practice, you will internalize all of this, and you won't even need any truth tables. Now, moving on the other hand, we also have the OR operator, which kind of works in the opposite way. So with our current example, we could use the OR operator to determine whether Sarah has a driver's license or good vision. And just by thinking about this, we can already intuitively imagine that the OR operator will be true if just one of the variables is true. And in fact, a look at the truth table confirms exactly that. So unlike the AND operator and the OR operator, even if one of the variables is false, the outcome will still be true. Or in other words, if either A or B is true, then the OR operation becomes true as well. And that's why it's called the OR operator. And once more, if we have multiple variables, it's enough for one of them to be true to make the whole operation become true as well. Okay, I hope this makes sense. And once again, I can assure you that it will make sense once we start using this in practice. Anyway, we finally also have the NOT operator, which is a lot simpler because it doesn't combine multiple values. Instead, the NOT operator acts on only one Boolean value, and it basically just inverts it. So if A is true, it will become false, and if it's false, then not A will become true. Simple as that. And that's basically how these 3 most important logical operators work. But of course, the best way to understand it is to use a more practical example. So let's go again back to using the age, and this time we set it to 16. And then we have our two Boolean variables. The first one is age is greater or equal 20. And the second one is age is less than 30. So let's determine the value of each of them. So if age is 16, then age is greater or equal to 20 must be false, right? And of course it is. And age is less than 30 is true, because 16 obviously is less than 30, okay? So that's the baseline basically, and now we will start to combine these variables a and b using some logical operators. So the first exercise is the not operator, so not a. And we know right now that a is false, right? So the result of not a, as we just learned, is true, because all it does is to invert the logical value of the variable. Next one, we have a and b. And we already know that a is false and b is true. So I'm just putting these values here again to make it a bit easier to follow, okay? So we have basically false and true. So from a look at our truth table here at the right side, we can easily determine that the result of this must be false. And so that's exactly what we learned before. So when we have the AND operator, it's enough for one of the operands to be false to make the result of the operation also false. Now we have A or B, and so let's check out the truth table in this case. And so in this case, we actually get true. And so this shows that it is enough for one variable to be true for the whole expression to be true as well. Next up, let's check not A and B. And we already know that not A is true and B is true. And so this time, for the first time, we are combining multiple operators here. And yeah, we already know that true and true will of course be true as well. And now another one combining two operators, so A, or, and B. And just as a side note, the not operator actually has precedence over the or and operators. So basically the values are inverted first and only then they are combined using and or. So we know that A is false and B is true. So not B must be false, right? Then false or false is also false. And actually that's the only way in which the or operator can be false, if all of them are false, basically. So I hope that made sense to you. And so in the next lecture, we will actually use these operators in code. And then it will make even more sense to you. So by then, we probably won't even need the truth tables anymore, because it will become quite intuitive how both of these operators actually work. But anyway, let's now move on, and I see you in the next video.